Hello friends, I am SK your tech tutor and welcome to my YouTube channel TechTuber once again. So as per my last video on Arduino tutorial, I said that the next video will be on sensors, but before jumping to the sensor part, I thought I should explain the PWM function, as here is most of the beginners are watching this video, so PWM is unknown to them, and apart from that many people doesn't know what PWM is and how it works actually. So I thought explaining the PWM before the sensor part will be more effective on my channel. So let's start the PWM explanation. What is PWM? PWM is that stands for pulse width modulation. A pulse width modulation, as per the definition, a pulse width modulation signal is a method of generating an analog signal using a digital source. And again I will explain, a pulse width modulation signal is a method of generating an analog signal using a digital source. What does it mean? Now for a digital source we have only 0 volt or plus 5 volt state, but analog signal may be different from that, maybe 1 2 3 4 5, anything that can be. So why we need an analog signal from our digital signal? If we are using a motor, then we need to control the speed, or if we want to control the brightness of an LED, then what will happen? Then what we will do? We have only 0 volt or 5 volt source, so in that case we will use the PWM function to control the speed of the motor or the brightness of the LED. That means we are creating an intermediate state of voltage between 0 or plus 5 volt. That is the main agenda of using the PWM function. So this PWM function consists of main two things. First of all, duty cycle. What is duty cycle? Amount of time the signal is on plus 5 volt state as a percentage of total one cycle time. What does it mean actually? Let us consider a square wave, complete square wave cycle, and it takes such amounts of time, and duty cycle says that the amount of time at plus 5 volt state, the amount of time plus 5 volt state is this. Let us consider this is T by 2. So the duty cycle will be the percentage of amount of time at plus 5 volt state with respect to the total cycle time. That means if we consider total cycle time T and the time on plus 5 volt state is T by 2, then the duty cycle will be 50%. This is called duty cycle. And now frequency determines how fast the PWM completes a cycle. Just for example, PWM consists of 500 Hz. That means 500 cycle per second. So in 1 second time there will be a 500 cycle in a signal. So now coming to the graphical portion of the signals, we are taking a square signal, and I have 4 graphs for explaining the PWM function. Now first, according to the first graph, there is a straight line along the x-axis at 0 volt state. So there is no pulsating signal, so there is no high voltage stage at this signal. That's why the duty cycle will be 0%. Then we will write analog write 0, and this analog and digital write function I had explained before on my coding video. So analog write 0, that means there will be no voltage output throughout the time, and the voltage will be at 0 volt state. And again coming to the fourth graph, now you can see there is also a straight line along the x-axis and there is no pulsating voltage, but this straight line is on plus 5 volt state. That means the voltage is at high state throughout the time and there is no pulsating voltage. That's why the time at high voltage is totally 100%. That means 100% duty cycle is achieved here, and we will write at the code analog write 255, because I had said before that the highest value of analog is 255 and lowest is 0. But in case of digital, we will write 0 or 1. There is only two state. But in case of analog, there is 0 to 255 number of states. And now for example, to create 3 volt signal from digital 5 volt and 0 volt state, we will use the PWM with duty cycle of 60%. That means output will appear 5 into 0.6 equals to 3 volt. For 5 volt, similarly, it will be 80% of duty cycle. Now you can see that duty cycle is very much important for achieving the output voltage. Any amount of output voltage can be achieved between 0 to 5 volt, but we need to have a clear idea about the duty cycle, and duty cycle will be explained in terms of analog write, the value of analog write. So again, from graph number 2, here we are taking 25% duty cycle, and the analog value will be exactly 25% of the highest analog value 255, that is 64. And you can see, as we are taking 25% of duty cycle, now you can see there is a total cycle. This is total cycle time, and the high volt at the time that is on high voltage, that is 25% of the total time. You can see that the 25% of total time is at high voltage. So that's why we are taking 25% duty cycle. This is the graph of 25% duty cycle, and the average voltage we will achieve at the output side after PWM function conversion, that will be average voltage will be 1.25 volt. This is the average voltage line. This will be 1.25 volt. And now again, from the graph number 3, we can see the duty cycle is 50% and analog write 127, that is close enough of 50% of 255, that is 127. And now, as this is 50% duty cycle, the time at high voltage state is exactly 50% of total cycle time. So this is the PWM function. Actually, PWM is the rate of change of voltage with respect to time. The PWM is rate of change of voltage with respect to time. We are controlling the width of the voltage, and we are achieving a certain amount of voltage which we need and which we can use as our wish. That is PWM. And so now this is the theoretical explanation of PWM function, how actually it works. But why, the question is why we are having average voltage at output side. So for any electrical device, any electrical or electronics modules, it takes some amount of time to achieve at the high voltage or low voltage. That means it takes some amount of time to achieve exactly plus 5 volt or to come down at 0 volt level. But here the time is very much low, and the pulse is very much high. The rate of change of voltage with respect to time is very much high. That's why our device cannot reach at the exact plus 5 volt state or cannot come down at 0 volt state with that faster time. That's why we are having average voltage of some amount with depending upon the duty cycle, 1.25 volt or 2.5 volt or whatever it is. That's why we are having average voltage at output side. I hope the PWM function is now clear to everybody. And if you have any question, any doubt about this PWM function, you can ask me on comment. I hope you like this video, and please subscribe my channel and share this video as much as you can to your friends so that they also can understand the PWM function. Thank you for watching this video.